Happy Sunday. This is PFG.Live, the podcast dedicated to the writings of internet philosopher, Hey Man, Why Didn't You? Hey Man, why don't you take your old 3D prints, unwind the filament, and use it again? Welcome aboard. We have a good crowd in Discord. We've been laughing all morning. Let's see. We have Mr. CS Waldfab. Wesley says it's 71 and mostly cloudy in East Tennessee. Carl Tauber in the People's Republic of Rhode Island says it's 42 degrees, cloudy, south wind, 9 miles an hour. Welcome aboard, sir. On the Discord, first in is Evils with a weather report that says there is weather and 21 degrees centigrade in a place. Bill Olney says it's in Rome, New York. It's 36 degrees Fahrenheit and sunny. Tucker in Buffalo, New York says it's 54 degrees Fahrenheit and sunny. Josh in Winnipeg gives us the METAR from a Charlie Yankee Whiskey Golf, where he says it's 360 at 11, gusting 16 knots, visibility 15 miles. Runway 31 has a visual range of 4,500, variable to 6,000 or more. Sky is clear. Temperature minus 15. Dew point minus 22. Altimeter 3048. Nick Weymouth says it's -1 science and a rare Wisconsin 4 kilometers an hour wind from the east. He says we've gone through the spring of deception and are into second winter. Nate Kramer from Las Vegas, Lost Wages, Nevada, says it's 73, Frank. 73, Frank. 10 degrees relative humidity, light breeze, a couple of vapor trails, but no clouds. Those aren't just vapors. Dale from Edmonton, Alberta, says it's -11 C and sunny in a place so dry the rain doesn't even hit the ground. That's true. If you follow us on Discord, we added Edmonton to our METAR list in one of our special channels, and he got Virga the other day. You guys can go look that up, Virga. Ted Hyde in Eustis, Florida, from Casa Frog Pro Resources at LEE. He says it is 160 at 6 knots, visibility 10 miles and clear. Temperature 28, that's positive 28, dew point 18, altimeter 3003. Remarks, playing Volt Nut today. Too many meters. Not really. We need to talk. Mr. Paul Morley says it's 81 degrees Frankenstein and sunny in Dallas, Texas. Welcome. Let's see who's checking in on the YouTubes. We got Carl. Indiana John says it's 34 degrees Frankenstein in Thornton, New Hampshire, and sunny with banjo music playing. Dave G says it's 70 degrees northwest Ohio, mostly cloudy, winds 24 miles an hour out of the north, and good afternoon. Let the wisdom and wit begin. Well, 1 out of 2, maybe. Welcome aboard, guys. Here in the Windham, New Hampshire, the National Weather Service thinks it is 43 degrees with 39% relative humidity, and the winds are out of the northwest at 8 miles an hour. Manchester Airport reports 150 at 5 knots, 10-mile visibility, overcast 8,000, temperature 04, positive, dew point -11, altimeter 3046, with all sorts of remarks. Hi, welcome aboard. Glad you could make it. Last week we had a pretty marathon session. I think we'll try to keep it tight this week. It's been a good week, very productive, lots of things happening, and we'll go down the list. Report from the Flat Cave. From the Flat Cave, I can report that 4-inch PFG stones are in process. We will have plenty of stock by Wednesday. And we have several orders, which will ship. What else is happening in the Flat Cave? Design is proceeding on the monochromatic illuminator for our measurement station for 6-inch work, 8-inch laps, and that is moving along. I needed some woodwork done for the housing, and I have to think about how we're going to do that. So that's what's going on in the flat cave. Everything is very solid. Systems are working well. Oh, Evils looked up the definition of virga. Precipitation not reaching the ground. That is what virga is. And then it goes, for example, virga. And he points out that it is self-referential, which I don't think he had to point out. I think you should point out that your comment is self-referential. But thank you for looking that up, Evils. Yeah, so that's what's going on in the flat cave. Everything's cool. Our snow got melted, and we had a 70-degree day. I sat outside and soaked up some sun. And then yesterday morning, we wake up, and there's an inch of snow on the ground. This is the hold my beer snow. It is gone. It has all melted, but it did happen. So I'm hoping it was the last slap in the face, but that's never true. We will get an April, like we had an April 1st snowstorm a few years ago. I think we've had an April 15th. We call that the tax day storm. We had that, I think it was either last year or the year before we had the tax day storm. So we're not done yet, but probably by tax day, April 15th, we will be done. It is the Ides of March also. Let's not forget. It's the Ides of March, and you should beware the Ides of March. Who said that? That's a quiz for you guys. So that's the update from the Flat Cave. Community notes. I don't think we have any major community notes unless somebody wants to raise their hand and say that they have a community note. Tucker's team that we talked about last week, they got into the finals. They didn't make it. They didn't win the competition, but they did a great job. What a great bunch of kids. And we congratulate them on their efforts. So, yeah, good job. And good job, Coach. Tucker was coaching them and helping them out, and that was super to see. What else can I think about here? Community notes. Proteum Machining has joined us. Welcome aboard, sir. So in Discord right now, we usually tell you who's in Discord. We got Paul Morley, Josh, Evils, Wesley. Hang on, we got to get to your button, Wesley. No, we're too slow. Dale from Edmonton, Ted Hyde, Carl Tauber, Proteum Machining, DBX, Tucker, AJF, Nate Kramer, and Nick Weymouth. Welcome aboard, Discorders. And you know who you are on YouTube right now. We got, is Wesley in both places? Wesley's in both places. CS Waldfab, Carl Tauber, Indiana John, and Dave G. Welcome aboard. So, last week we talked a little bit about filaments and the out-of-stock situation at Bamboo. And so I wanted to follow up on that. I posted the thumbnail for this video, and it says, "Where's the filament?" So I just wanted to, point out that this is for Carl. Carl, this has the filament inside of it, and the reason we ask the question, "Where's the filament?" is we can't see through this metal shield to see the filament inside of this vacuum tube. So for you kids at home who are under the age of, I don't know, you'd have to be over 50 to even know what this is. This is not only a vacuum tube, which has a filament in it because it has to heat up in order to do its job. This is a digital vacuum tube. This is from a Burroughs computer or calculator. I haven't looked it up, but if you guys want to nerd out, this is a Burroughs BMX switch type BX2005. And I bet you didn't think you'd wake up this morning talking about the filaments inside of a vacuum tube, but there it is. That's for you, Carl. And, anybody else who's an old computer hack. So where is the filament? So last week we had bamboo just went like out of stock. No filament. Have a nice day. I successfully placed an order with Overture on Amazon. I think Amazon owns Overture. And I placed an order for 10 more rolls of filament. And they broke it up into 4 rolls, and 2 rolls. Now, I assume that means it's coming from 3 different Amazon warehouses to get me my 10. And that's fine. I don't care. But what it was an indicator that stuff is happening, and that was Overture filament. Okay. Well, this past week, midweek, I go looking, at the situation, and everybody is out of stock on everything. So I started looking into this and wondering, what is causing the problem. I had a nice chat with my eager intern. You might know him. His name's Claude. And there were all sorts of theories. I talked to everybody on the Discord server. And one of the theories was because it's coming from China. We had Chinese New Year's, which I think was mid-February, and Bakafish, who, by the way, Bakafish's sticker is being prominently featured on the mic stand sticker position today. Bakafish says that basically everything shuts down for 6 weeks in China at Chinese New Year's. One possibility. And Evils tells us he is right now having soup with carrots. Anyway, so that's a possibility. Next possibility, of course, is tariff situation. The U.S. government dropped the so-called de minimis rule, which means if your stuff is coming into the U.S. and it's small amounts of stuff, that you're not going to get tariffed. Well, that has been dropped, so you're going to get tariffed if you come in with a toothpick. So that's a possibility. The oil situation, because oils are used in the making of filaments, depending on which one you're using, and that was, of course, now the situation in the Straits of Hormuz. And for more information, I refer you to the Colbert Report, where you can find Hormuz news you can use. You're welcome. All of these are possibilities. So I talked to Claude and I said, what do you think, Claude? And Claude started grinding away at possibilities. So I said to Claude, please make me a table of all of the filament suppliers, links to their sites, country of manufacturer, and whether PLA and PETG are in stock. So I'm going to show you what my eager intern did. And it did an okay job. I'll point out that getting this actual table as a table, it actually took a little bit of work. And I said to Claude, how can we shorten that in the future? And Claude said something like a rendered table. Ask for a rendered table or a visible table or something like that. It gave me a bunch of code at first. So here's the situation that Claude thinks is going on. The first 3 columns are useful. The second 2 columns are not useful. So it was the company, the link, country of manufacturer. You will note that, of course, Matter Hackers, I don't think is it's a distributor. It's not a manufacturer. So it says various countries. But then the only other countries that aren't China was IC3D, which I actually haven't checked with. They're in Ohio, USA manufacturer. Never used them. Don't know anything about them. Atomic Filament in Indiana. I misrepresented them earlier as being in Texas. They're in Indiana. I haven't checked. Well, I did check with them, and it was negative. And of course, Prusament, which is in the Czech Republic. Now, it's not only in the Czech Republic because they set up a manufacturing facility in the United States. And if you recall, we talked about that before, and there was a video about that. 3D printing nerd visited that facility. So Proteum Machining says Atomic makes some great filament. Thank you, sir. We'll have to check it out. But I found, and I did not check on Prusament, okay, but I basically found that all my sources, and of course Bamboo Labs, Polymaker, and Overture are my top 3 sources, were out of stock. Then I tried to figure out if it was a PETG versus PLA problem, and I didn't get much traction on that. But my sampling of the suppliers were all out of stock. Now, I just got word this morning from Paul in Dallas, and he said that he's starting to see a trickling of restocking on the Bamboo site in the last couple of days. So that's a possibility, but it's dynamic, is how we left it. So the bottom line is that, yes, there is a filament problem. Getting filaments is currently challenging. Will it clear up in the next couple of weeks? I hope so. I am going to look at setting up a second source, which is a U.S. manufacturer, and see if that is a good thing or not. So we started using the term second source, and I think it's very important if you have a bill of materials for a product that you have your primary source and you have your secondary sources. And second sources are important. So we need that now on filament. Go figure. If you're not using filament in your, production or as tools for your production, don't worry about it. But otherwise, worry about it because it's a thing right now. So if anybody has any information they want to add, please put it into chat. Proteum Machining says the scarier problem is the carbide shortage right now, in my opinion. So I am unaware that there was a carbide shortage, so thanks for bringing that up. Yeah, I can't. So Ted, too much to read, but apparently California is trying to ban some things like polycarbonate filament. I know nothing about that. Canadian site as of right now, this is for PETG-HF, which is Bamboo, and Dale just posted it, and it's 100% out of stock, all colors. So that's what Canada's seeing from the Canadian side. So it doesn't hurt to have a little excess inventory for your needed filaments. And in my case, red PETG is the number one. I mean, that's, every single order of PFG Stones goes out with a red tray. So if I run out of red PETG, I am not going to be happy. Proteum Machining says the U.S. side of Bamboo has some PETG. Of course, not red. Thank you for pulling those guys. It would be kind of cool to have a dynamic website that monitors all the suppliers. I bet you we could do that, huh? So that's the situation on filament. If anybody has any additional information, like, feel free to message me and we'll try to bring that into the situation. Yeah, Proteum says that that our intern can whip that up in an hour or so. It's a good idea. Bill Olney says it sounds like a project for the intern. It sounds like an even better idea. And Proteum says we could add it to the Discord bot. Okay, we need a software team. You guys let me know who you are, and we'll start cranking on that. We have some bots on the or either on this Discord or serving the Discord right now. that we've had for fun, doing weather stuff and other things. But it would be interesting to do that. Okay. That's the news on Filament for your 3D printers. So the main thing that hit me this week led to our main title today, which is Drawings and Schematics Are Graphic Novels. And the reason I say that is a buddy of mine, Mike, and his channel is Microwave, MIKROWAVE, digit 1, Microwave 1, on the YouTube. He came over. I did some work for him. He did a video, one of his normal videos, but I was in it. If you want to see that, check it out. It's on the channel. Thank you, Mike. It was a lot of fun. And, well, anyway, he had sent me a schematic, and I have to be a little obtuse about it, but he said he was doing some research, and he got the schematic for a regenerative receiver. Okay, so this is an electronics schematic for a receiver. And he says, this thing is really hurting my head. I am trying to figure out this part and that part, and it's just weird. Now, Mike and I go back, a long time in electronics, and we both have been in the industry doing RF stuff, and we're both hams for 40 years. I mean, easy. So we're looking at the schematic, and he sent it to me, and I said, "Oh, I could read that, Mike." And I started looking at the schematic. I get a headache, and I started to break it up into pieces and redraw it, and then I stopped, and I said, I can't do this right now. It was pretty time consuming, but then it hit me is that is an art. The ability to draw a good schematic and transmit the information is non-trivial, and it extends to drawings and machining. So simultaneously, and this is why it all kind of came to a boil. Oh, Carl's here. Stand by. Mr. Carl Tauber from Rhode Island, you are on the air. Hello. We're trying, Carl. No, I'm not hearing any audio from you, but all right, we'll try later. So I've been working on this project, and that was in the thumbnail that you saw earlier, and I was making a drawing this week at the same time that I was dealing with this schematic that Mike was just getting a headache over, and I realized we have to talk about this. And in recent years, of course, the term graphic novel has infiltrated my household because I have an artist, Sam, who is awesome. And so we've talked about graphic novels and favorite graphic novels and the style of a graphic novel. And I realized that a schematic and a drawing are graphic novels. They are ink on paper. They tell a story, and they're relatively simple. So I asked for some examples of drawings from some of my buds, and I wanted to share it with you. Here's a schematic, or here's a drawing that is just going to make your eyes water. And there's an example of where do you start? It's too busy. It's like, I'm going to pour every single detail onto one page. Here's another one, also like crazy busy. And we're going to talk about these in particular. Yeah, Bill only says, good thing I already took the Excedrin. Yeah, it's true. Evil says, professional engineer, not a professional draftsperson. Okay, so in the old days, I could say that now. In the old days, you did have drafts people, and you did have people whose job it was to make the drawings, and you had engineers whose job it was to make the designs, and they were not the same people. But what's happening now is that they tend to be the same people, and the industry wants them to be the same people because it costs less, they think. So with our electronic tools now, you go in, think about fusion, right? Let me show you some other examples before we jump into the argument about fusion, which I think is a good one. The same thing happens in electronics. I'm just going to share with you some lovely, electronics drawings. We'll take a look at these here. Here's a very good schematic. I couldn't find the one I wanted to show you, but this is an example of a very good schematic. It's very clean. The signal flow is left to right. Everything is done nicely. You can read and understand this schematic easily, almost trivially. There's a big view of the same. Here's another schematic. This came out of an ICOM radio. Again, note the use of color to show certain signal paths. Very clean ground symbols, so there's not excess wires all over the place. Very nice. So there are ways to do, good schematics. Here's another one. This is actually a big shot of the part of the ICOM schematic, and it's very clean and it's easy to read, and you can follow the signal flow. I can tell you that the schematic that Mike showed me was not. So I started working on a drawing, and let's see if I could show you this drawing. Yeah, here it is. It's nothing crazy. It's the fill adapter that I've been working on. This is a work in progress. This is not finished. And this is page 1 of that drawing. Okay. So Proteum says, I still want one of those wonderful old drafting tables with the built-in rulers and protractors. Yeah, except clutter credits. I get you. I actually have some cool old drafting things, which I still keep. And who else had the? We have to go back to main. Mr. Tim Beatty says schematics are a directed acyclic graph. You're welcome. Thank you. I don't know if you know this, but Carl Tauber and I played bass for directed acyclic graph back in, was it 79, Carl? I think it was back in 79. Dave is jumping in to say that my tool supplier was saying China supplies 60 to 80% of the world's carbide and is restricting supply. ISCAR is supposedly not supplying carbide blanks to anyone. Keep it for their own products. That's amazing. Carl says old Tektronix schematics are the best. They fold out so that you could look at them while reading the circuit description. Yeah, I was looking for one of those, but I couldn't find it in time. So getting back to this, so this is a drawing. I just started working on it, and I like to use minimum ink for maximum information. So the information to ink ratio is very important to me. So let's talk about that for a second. If I show you this, I apologize to the guys on the podcast because you're not seeing this, but you'll catch it later. Okay, I'm going to show everybody this, and you tell me what you see. Ready? Go. Tell me what you're looking at. Paul just dropped a drawing. Okay, Proteum says bird. Josh says chicken. Paul says canary. Bill says angry bird. I like that. Evil says penguin by Picasso. It's not a penguin. The penguin's a different one. But this is a bird by Picasso. Yes. So what's the ink to information ratio on this one? Right? Pretty impressive. All right, let's see if we could do another one. All right, same thing. Tell me what you're seeing. You ready? And go. What are you looking at? Anybody? Bueller? Yes, you are correct. Evils. It's a Feynman diagram. Okay. Now, if you ask me to interpret the Feynman diagram for you, I am not an expert.
I am not an expert.
And I can't really do that right now. However, this is a description of a quantum physics interaction that would take equations that will blow your brains out your ears to describe. And Richard Feynman, through his invention of Feynman diagrams, has made it very simple, very high information to ink ratio, very high. And I love it. In my world, we have something called the Smith chart, which I don't have an example to show you right now. And that also allows you to do what literally complex calculations with a couple of lines on a chart. And the chart is the magic. Okay, so there's examples of very high information to ink ratios, and this is what I think we should be striving for. I am not an expert. I'm working on getting better at it. But one of the things that happens in Fusion is that we work really hard on making the model, right? But the model, and especially the 3D model that we use for 3D printing, right? It's like, oh, I got my 3D model. I'm going to go print it. Well, if you're machining a part, the model does not have enough information. I'm sorry. So we have to make drawings still, and it is a skill and an art. So again, I consider myself a noob on generating proper drawings, but I sure am trying hard. And what a drawing should have is everything the guy at the machine needs. Okay, sometimes the guy at the machine is a programmer sitting, writing G code, but in a tool room situation, it's literally the guy at a machine is going to be holding a drawing and making your part. If your drawing enables the machinist to make the part without picking up a pen, then you have succeeded. And that's hard. That is hard to do. I don't know any. Dale, has there ever been a time, Proteum, has there ever been a time when you didn't have to pick up a pen to get a part made? And don't comment on whether it was one of mine. That's not the point. So what I like to do is open up with a page which is the general drawing, a 3-view drawing. I always like to put a rendered couple of isomorphic views to show, so the human brain can get a head around what this thing looks like, and then a 3-view so that you could start to look at actual numbers. So this is a start. Now, what I realized I started doing is I like to make sub-drawings, additional drawings for specific purposes. So this part is going to be made on there's 3 operations, but the first 2 operations are using
lathe tooling.
That's correct. Lathe tooling. And a lathe operator is going to be making this. So in the first drawing, I show kind of which sides are getting which op. So here, the left side says this is where op 1 is starting. And obviously there's going to be a flip in the lathe, and then op 2 is starting on the right. We have a few dimensions here to get the party started, but really this is insufficient information to start cutting metal. So then we go to page 2. Page 2, for example, looks like this. This would be op 2, and this is how I started. Now, I like using the the incremental dimensions. I forget the name of it, because that's how your machine works. So typically you're going to face off the part, and that's going to be 0, and then you work your way in. So I could stand at the machine and program this, or I could stand at a machine and turn this, and I have enough information to get the job done. This isn't finished, so don't, this isn't presented for analysis, but that's what I like to do. So I like to have a main page and then a sub page, at least for each operation. And then sometimes you have to have detail sections where you go in and show some details. For example, on this one, there's an O-ring groove. I think I can get the job done without a detail section on the O-ring groove, but we will take a look at that when we get to it. CS Weldfab, you're very good, sir. He notes that there's a weird thread there. Yeah, so this part, which, by the way, here's the model for the part, right? I have one of these, and I'm reverse engineering it. Okay, the full disclosure, this is a reverse engineering job, but we talked about this before, and I had to nail down the threads on this part. So the small threads, the ID threads, turns out after a little sleuthing, was lovely M14 by 1 millimeter. So that's standard as standard comes. However, the OD threads that you see, the big fat threads, are meant to go into a scuba tank valve. And the O-ring, of course, is a seal on the face of that valve. So, what is that thread? Well, I was hanging out on Discord while I was doing my research, and I was talking to Dale, and I was talking to, whoever was there. And this was not trivial. This was not trivial at all. We were able to figure out that it was 14 threads per inch, but that's where the similarity stopped, because the outer diameter was weird. It was not obviously metric. It was not obviously imperial. And I was having a hard time figuring it out. I think Dale guessed at a pipe thread. He said pipe thread, and I'm like, that is very possibly the path to the answer. CS Weldfab says it's a paintball standard. Yeah, I'm learning that. And this, of course, is for air pistols. And air pistols, paintball, it's all like one big happy family. Yeah, Dale says pipe sizes for the win. And it was a win. So it's not yet on this drawing here, because I haven't finished it. But on the big drawing, I did note it, right? So here it is. G 5/8 by 14 BSPP. So from my understanding, the G is good luck. The 5/8 is 5/8 of an inch, which has nothing to do with the size of your threads. By 14 is 14 threads per inch. BSPP is British Standard Parallel Pipe. Did I get that right? Did I get that right, Dale? So thank you very much. Dave G says, I received a print 7 years ago that I needed so that I could make fixturing to machine a die-cast part. After studying it, the print was drawn incorrectly in several places. Yeah. Well, my goal is to make this part absolutely correct, because after I make a dozen of these things, I'm going to hand the parts plus the drawings that I just did, plus over to the MIT pistol team, and I'll keep making them, but they'll have it in perpetuity so that they can reproduce them. Yeah. Dave, you and Dale need to talk because I've heard these stories. Dale just had 50. Yes. Thank you, Dale. And it's 55 degrees. I didn't show it on the drawing because, as you know, when you make this call out here, which is the thread call out, it will imply a 55 degrees. So I'm scratching my head and I realized, I need 55 degree threading tooling to cut this on the lathe. So I ended up, Dale helped me. I ended up identifying an insert that'll go on my threading tool, and we will be all set for that. So those are ordered, and those are coming in, and those are carbide. And I think I'm getting in under the wire. So step one in my mind is, Eric says it sounds like you need a comparator now. Okay. I'm going to show you my comparator. You're going to laugh. Can I reach everything? Yeah, I can reach everything. Here's my comparator. You start with a piece of Saunders Latheworks note paper. If you don't have that, you can probably, you take your part. We'll do the OD here, okay? And you wrap the paper around it, okay, like that. Give it a nice pinch on the paper and give it a twist. Okay. Now, on the paper, you have focus. Thank you. You have the markings of the thread. And now you could write, you can count threads. You could make a little nomenclature right on the paper. And then you get out your calipers, my Mitutoyo calipers, and you measure them, and it will hit you in the face and say, yeah, dude, this is 14 threads per inch. So there's my comparator, and it works great. And I'm sorry, John, if you get inundated with requests for comparator paper, but give it a part number. And Eric says, but what about the crests and radii? So once we went looking at the table, we found a table on the intertubes of British standard pipe threads, and sure enough, it listed the OD, the major diameter in millimeters, which, by the way, push a button and you're in millimeters land. That's easy. And I was able to identify it. I found it. And Eric, you're not wrong. So the BSPP does have something to say about the crests and the radii, and I have thought about that. So we're getting there. And CNC machine will help us with that. So Evil says G stands for gas, and R is for roar. What is roar? Could you translate that for me, please? Eric says the Engineer's Black Book is an excellent bench reference for threads. Yeah, there's two books that I have on my shelf. One is the Machinery's Handbook, some edition, and the other one is the Engineer's Black Book, which I like a lot because it's smaller and quicker. Rohr is German for pipe. Gas is German for gas. Really? Do you pronounce it the same? Yeah, Dave says we could talk about paint gun pressure supply adapters also. Topic for another day. I want to talk to you about that because I think we're in the same boat. We're just dealing with Hammerly air pistols for the most part. So, as you make your drawing, you've got to think of the person who is using your drawing. So, if you're a small shop, and as you know, Kinetic Precision is a pretty small shop. I'm the engineer upstairs, and the machinist downstairs. He's a little weird, and they're both me. So I think of what I need when I'm downstairs doing my thing, and I try to make my drawings so that it's all in the drawing. Yes, a paper drawing, and I don't have to pick up a pen. And if I don't have to pick up a pen, I win. Dale was making some really good commentaries. I dutifully put the thread specification, on the drawing. But again, if the guy's standing in front of the machine, what does the machinist need to know? Well, the major diameter, minor diameter, and pitch diameter of the thread, so that the machine could be set up properly, the threads could be measured and checked against the drawing, and life is good. Otherwise, as currently drawn here, even though I was, and again, this isn't finished, so bear with me, but I would have to go running to Machinery's Handbook to look up those numbers and then write it in pen on the drawing. And what does that do? That fails the test. So you could put the numbers on the drawing. Just put it in notes. This is a thread spec, and here's 3 magic numbers. Boom, boom, boom. Yeah, exactly correct. Dale says, and that guy in QC is a real jackass. He is. He's a pain. He's a real pain. So make the drawing. Your model's perfect. Your model is drawn
perfectly.
And now you have to go make the drawing against the model, and you have to make it for the guy downstairs. So I like to do multiple pages, and each op gets its own page. So if I'm machining from the right side of the part, I have a page for that. And if I'm machining from the left side of the part, I have a page for that. And I pick up all of the important numbers. And then finally, we stick a hole. It's a relief hole. Now this is going to have to be done in the mill. I think this is going to be done in the Bridgeport because it's not a big deal. But if you look, you'll see this little hole right here. And we really do have all the information we need on page 1. So I don't think that guy is going to need its own page, but I'm not adverse to making it so. So we'll see what happens. I'm not adverse to adding pages. You should have as many pages as you need to eliminate the need for a guy to get out a pen when he is working on each of those ops. But not too many pages. And again, the litmus is if you can give it to the guy downstairs and he never has to take his pen out, that's 100% on the test. The next thing is sign your work. Okay. Now, I know who drew mine, but sign your work. If you go back to our friend Pablo, he signed his work. How much do you think that artwork would cost? I don't know the answer, but it's pretty impressive, the price to ink ratio in this case. So there you go. The other thing that makes your drawings and your schematics a graphic novel is that they tell a story. So if you have dimensions on a drawing that are there for a specific reason, that are really important, call it out. Tell the guy at the machine who's making your part, who's programming your part, who's making it happen, hey, this is the critical surface in the whole thing. Now, officially, again, I have to repeat,
I am not an expert.
Officially, you put in surface roughness and all this kind of stuff, but it's okay to tell the story in the drawings, and it should tell the story. Same thing with calling out materials. What material you're going to use in this part. Don't forget to do that. Dale has been making some parts out of some real unobtainium, and it's not fun. as he will attest, when something goes wrong on that really expensive material. So make sure it's clear on the drawing. Interesting. So Eric says, and I haven't followed the story, Picasso is an interesting guy. He became a world-renowned artist as a child and then became incredibly bored with the art styles of the time. So he started deleting increasingly more parts of geometry. It's an interesting story because it sounds a lot like the story of Muntz. So we've talked about Muntz before. M-U-N-T-Z. Muntz built a company making televisions at the beginning of the television era. And it was I believe it was in New Jersey. It might have been in New York City. And he had a production line making TVs. And he would walk down the production line and point at a component and say to whoever, what is the purpose of that component? And if they didn't answer him quickly enough, he would grab a wire cutter and cut the component out. And if the TV kept working, that component was gone. And that was a cost reducing thing. Now, it wasn't necessarily a good idea because it eliminated the generality of the design. So in other places in the country, the TV wouldn't work. But that's another story. So Picasso simplified. Thank you, Evils. Evils found Muntzing in the Wikipedia. But that's what Picasso got to, right? And that, that's pretty amazing. So do you need to do that in your drawings? You might need to do some of it, or else your drawings are going to start, looking like that. These guys could use some help. And I think this drawing is horrible. If and only if you're handing this to somebody to make these, which they were, this is going to give somebody a headache and more likely lead to errors than if we did what we said. Give the overview, give each operation its own subdrawing. Eric says, my brain hurts. Yeah. Mr. Tim Beatty says, no datum, no bueno. You are not wrong. And Dave G says, I think with respect to the artwork, maybe a commentary on the whole world of artwork, more or less than a banana taped to a wall. Even that requires a little maintenance, so I don't think that's as simple as it could have been. Yeah, Dale confirms many errors have been made on those parts because of those drawings. And this is my commentary, sucking so bad. So if your drawings are a graphic novel, they have a beginning, a middle, and an end. That would imply that not only does it give you the overview, give you each ops information so that you can make the thing, but also part of the drawing should be information on final acceptance measurements, if that's what it takes. Yeah, so we have computers these days, right? So everybody forgets how to do drawings because it's not their primary thing. Many problem drawings come in from engineers, and this is both anecdotally and I've personally witnessed this, with dimensions to 4 decimal places, just everywhere. Now, if you've been doing this a little while, you know that there's a procedure where you could specify if it has 1 decimal place, it's plus or minus 10,000ths of an inch, for example. If it has 2 decimal places, it's plus or minus 5,000ths of an inch. If it has 3 decimal places, it's plus or minus 2,000ths of an inch. And if it has 4 decimal places, it's plus or minus a 10,000th of an inch. I'm making those up. It depends on whatever your standard is. But if you don't put that on the drawing and then you just march in with 4 decimal places on everything because the drawing was made by the engineer, that's like a good clue. That's horrible. So now the guy making the parts has to go back and he has to ask. He's like, hang on, dude, what's the important dimensions? And now the machinist, the fabricator, is turning into the guy editing the drawing. Also, Dale pointed out, make sure you get a signed drawing. So if they make a change, you say, fine, send me the drawing with the change and sign it before you start cutting unobtainium. Yeah. And then sign your work. So I'm going to continue on this little project to the point where I can feel good about giving my drawing to the guy downstairs, and then we can start cranking these guys out. And these are for the MIT pistol team, and they're for their air pistols. MIT routinely does very well in intercollegiate competition, and they have produced people who have gone on to the Olympic team. So that's pretty cool. So that's the story on that. If you guys have questions, comments, or epiphanies, please feel free to put them in the comments. Let's see what else is going on. There's no errata from last week, so we don't need any of that. Dale's typing, so I'm waiting for him to finish typing. Here we go. Dale says, also have one you can read that hasn't been drawn, that hasn't been drawn with a half-eaten broken crayon. Absolutely true. I think the concept of a paperless system is nonsense, because paper is a very high resolution display at low cost, and you could write on it in the field. If I said to you, I'm going to give you a high resolution display, you can carry it anywhere you want, and you could use a simple pen as data entry to that screen. Would you get excited? And if I told you further, it doesn't use any power. That's awesome. Yeah, that's what paper is. I'm seeing DBX is recommending also that when you, let me show you what drawing I'm talking about. So when you do these drawings, you don't have to accept the standard fonts. DBX is recommending Comic Sans for all of the information on a drawing. Okay, so if you guys could change over to Comic Sans, yeah, that would be great. That would be great. Thanks, DBX. I appreciate the update. So, guys, I have to wrap it up here because I have to go make sure my doors are locked because DBX is going to come beat me on the head. Evil says Comic Sans is considerably more readable, which should indeed be considered. Thank you for taking half of the fire for me, Evils. Eric says Didact Gothic is my honest preferred font. We're taking notes here. Beautiful. Oh, Mr. Tim Beatty is yelling at me. He says you can't parenthetically have metric 25.4 millimeters with 0.001 inch with the same tolerance to decimal place. Mixing is confusing. Well, I would argue, sir, that the primary the primary dimension is the dimension, and the other one is a commentary. Okay, so we're in America now. Speak Imperial. You're welcome, Unix Carbide. Okay, I know there are standards, and there are so very many of them. And as long as, the drawing is clear and it meets the standards it has to meet, I'm happy. In the meantime, if you need some PFG stones, head on over to PFG.Stones.com. Kind of logical, right? We have... somebody asked me, it was Mike. Mike was over here. He says, who do you sell these stones to? And I told him, I said, we're up to 20 countries and counting. So they're going all over the globe. And I stay busy every week trying to help that one machinist, that one tool maker, get that one project perfect. And I really enjoy it. Eric says he just bought a set for himself. Yes, you did, sir. I packed them with these two hands. Yeah, Evils correctly says that if you use, I agree, if you use either metric or US customer units, the machinist is likely only to be using one of them. Supply that. So, yes, that would reduce ink, wouldn't it? So that would be a not unreasonable thing. So if you need PFG stones, head over to pfgstones.com. If you have questions, don't hesitate to reach me at the contact page on the pfgstones.com website, which is Kinetic Precision. And other than that, I enjoyed being with you guys today. We're going to have an after-party roundtable after the show. Get flat and stay flat, and we'll see you guys next week.